I want to go ahead and turn over the presentation to Nicole, our additive manufacturing lead at Saratech. Thank you so much, Nicole, for joining us today.
Thank you, Nika, and thank you all for joining us today as well. I've spent over 15 years in manufacturing and utilizing 3D printing to get products out on the market into your customers' hands as fast as possible. And I wanted to create this webinar to highlight the benefits to your organization by incorporating 3D printing. Andrew will share, the advantages of local and facility uses for 3D printing, from your development of parts through the end-use components, including your system. Andrew will walk us through the technology and review case studies that focus on applications and materials. Now, let me turn this over to Andrew Marzban, our technical manager. Andrew, thank you so much for joining us today and teaching us more about 3D printing capabilities and applications.
Thank you very much, Nicole. Glad to be with you all here today. Yes, my name is Andrew Marzban, Additive Manufacturing Technical Manager. I spend pretty much my job is to help customers adopt additive manufacturing and 3D printing technology. So that's what we're going to talk about today. So a brief overview of what we're going to talk about. We'll discuss how you can utilize 3D printing technologies in many aspects of the product development lifecycle. So first, we'll briefly discuss 3D printing technology. Then we'll talk about the product development lifecycle, or PLM, product lifecycle management, and we'll see areas within that lifecycle where we can benefit from 3D printing technology. And this will include aspects such as product design, assembly and inspection, as well as manufacturing of end-use parts. We'll take a look at some applications from real customers that are benefiting from the technology. And lastly, I'll tell you a little bit about Saratech Services and how we can help you with these technologies. So let's go ahead and get started and talk a little bit about 3D printing technologies. Now, 3D printing has been around for decades, but we really haven't seen a widespread adoption until kind of recently. And part of the reason for that, I think, is because there are old perceptions out there that 3D printing is slow and expensive. They do have a reputation of having a poor surface finish. So you can see this part photo in the bottom right here. Doesn't have the best look to it. And they have a reputation of being weak. There are these gypsum powder bed machines that crumble and are very easy to break and fracture. And a lot of engineers think of 3D printing as like duct tape. So as an engineer, we love duct tape, right? But we don't think of it as an end solution to anything. We think of it as a quick fix. And this is really, it's not the case anymore. 3D printing technology has come such a long way. It's fast, it's cost effective. As you can see from this photo in the top right, the surface finish is excellent. The machines have high tolerances now, and they're using engineering strength materials that have been tested and have data sheets with them. So it's really come a long way. And I think that's part of the reason we're seeing the adoption. Now, why use 3D printing? Well, traditional methods aren't going away. Your CNC mill, lathe, injection molding machines, they have their foothold and their use cases. However, additive manufacturing can be another tool in your toolbox. They can be used to replace some of these traditional methods in some cases, or you can use them to augment and improve your traditional methods. Think about a hybrid solution. Maybe you can't replace a machined metal part with a 3D printed plastic part. Okay, but you can 3D print the work holding fixture, and that has great time and cost savings associated with it. So that's kind of some of the use cases we'll look at are similar to that. Now, this is the way the market is going. So a study by Grandview Research estimates that the 3D printing market will grow at a compounded annual growth rate of 22% for the rest of this decade. And they already estimated that the 3D printing market is valued at over $16 billion in 2022. So it's gonna keep growing. And this adoption is across all industries. We're seeing it in healthcare, automotive, aerospace, defense, you name it. And other factors like the desire to reduce greenhouse gases, for example, and the COVID supply chain issues we've seen in the last couple of years, these are only pushing the market to adopt additive manufacturing technologies even sooner. So a little bit about Saratech and the product development lifecycle. Saratech provides engineering solutions in order to help companies realize better products. We offer engineering services, software, and manufacturing solutions to improve the product development process. And we see additive manufacturing as an important part of that process. I think that a lot of people only see it useful in maybe the design and prototyping phase, which it is very useful in those cases. However, it can have a great impact on the other aspects of the product lifecycle too, in your development, your validation, and your manufacturing. So these are the aspects we're going to talk about today in the webinar. It's not a complete list by any means, but we are going to talk about how 3D printing can be used specifically in product design and prototyping, assembly and inspections, and lastly, end-use part manufacturing. So in order to do this, I'm going to present these different applications, and each application is going to showcase a different 3D printing technology. In engineering, it's super important to choose the right process and materials for your application. And for that reason, Saratech has a variety of 3D printing technologies in-house that we have available to use. We'll briefly talk about the HP 3D printing multi-jet fusion technology, which is a powder bed solution. It's a really great 3D printer that can substitute injection molded parts in small volumes. We have Markforged 3D printing, which is a composite printer that can print extremely strong parts with reinforced fibers in the part, and it's a great drop-in replacement for machined aluminum parts. If you route the carbon fiber in these parts, they can be as strong as 6061 aluminum, which is incredible for a plastic 3D printer. And lastly, we'll see an application using the Big Rep printer, which is a massive build volume printer. It has a 1 meter cube build volume, and it works with a variety of different thermoplastics. So we'll see a great use case with that. So let's start off with product design. 3D printing will enable you to iterate and get your design into production faster. You'll have faster access to prototypes by cutting down on lead time for machine parts, which in some cases can be weeks or more. And you'll be able to test out multiple designs simultaneously, which would have been cost prohibitive, say you were machining them, right? So you could print multiple iterations of one design, and if you're using a fail-fast method, you can hone in on the design that is going to work best for your application. And also another benefit to 3D printing your designs is that you can have design reviews with your colleagues. You can collaborate on your ideas more effectively. So let's look at our first application. This comes from a company called Centaur, and they manufacture high-end windows and doors for residential and commercial applications. They have premium products, and their doors and windows have these very complex folding hinge mechanisms. So to test their designs before production, they had 3 full-time machinists to produce their prototype parts. And oftentimes these machinists were so busy making parts that they would also have to supplement and outsource with other companies manufacturing for them. So as you can imagine, this led to a couple issues. First off, inconsistency, right? If they were not manufacturing the parts in-house, they had less control over the quality of the parts they were receiving. And outsourcing parts is pretty slow. You have typically lead times of multiple weeks to get your parts shipped out to you. This company, Centaur, adopted the 3D printing technology from Markforged, which, if you recall, is a nylon-based 3D printer that can route continuous carbon fiber and other sorts of fibers in your parts to make extremely strong end-use parts. And they adopted the technology and were able to cut down their lead times for prototypes. Instead of weeks for manufacturing, they were able to print in-house in just 12 hours for a lot of their prints. Huge time savings. You can imagine how much that speeds up their product development. Even better than that, they were spending $800 for a part to get manufactured. With the printer in-house, just in $10 of materials, they were able to get prototypes that were able to help them evaluate their designs. So this is a really great example of using 3D printing within your design step to get your product tested, validated before you can move into production. So the next application that we'll talk about is assembly and inspection. So this would be the next step in your product development, right? So 3D printing can assist with the assembly and manufacturing, and it can help you make custom jigs and fixtures that would take otherwise a very long time, as we'll see in our next example. And it will also help you reduce changeover times. 3D printed fixtures are much easier to update and change and print than it is to make a traditional fixture that may be machined, have calibrated parts on a breadboard. So let's go ahead and take a look at our example of this. And this comes from Ford in Europe, where they are manufacturing passenger vehicles. And one of this here is a welding fixture. So you can see in this photo here in the bottom right is a welding fixture that they have. It takes over 190 parts to make this fixture. And it's all traditional parts, breadboard, standoffs, toggle clamps, all of the things that you would use. And you're using this on these body panels and other parts. So it takes a technician a very long time to set this fixture up. And there's no reusability to it. So could you imagine just spending weeks and weeks and weeks making this whole fixture, and then the next model year comes out, the body changes, and you have to start from scrap all over again. It is a huge time sink to have your manufacturing go through this process every time. Now, they purchased a Big Rep Pro printer. You can see it's that printer we talked about before. It's a massive build volume, has 1 cubic meter, and it can print with a variety of thermoplastics, PET, ASA, variants of PLA. So very versatile machine. And this entire fixture that previously took them over 3 weeks to set up and tune, they were able to replace it with a 3D printed fixture that took them just 3 days to print. Absolutely incredible. The owners of this machine said that with all the time they spent on labor setting up these fixtures, after they adopted the Big Rep machine, the machine literally paid for itself after just 3 prints. That is really an incredible use case. At the same plant, manufacturing plant at Ford, they're also using it for a variety of other things, such as making these alignment tools for the badges that go on the back of the vehicle. And they're able to make these parts overnight. So they're not shipping out, waiting weeks on end to get custom parts made. And as soon as the car gets updated, as soon as they have a new body style, they can 3D print that again and have it in use the very next day. So really interesting use cases of how this can be used within your manufacturing plant, supplementing your traditional methods of manufacturing. The last aspect that we'll talk about is end-use parts manufacturing. So this is very interesting because, like we talked about 3D printing being duct tape, you would never think of selling a product that is duct taped together. But with the HP technology, it really can make these end-use parts in medium to low volume production runs. So typically, if you are going to be doing hundreds of thousands of units of a part, it makes sense to spend the money on tooling and injection mold it, absolutely. But if you're making medium to low volume, then you have to weigh out whether or not it makes sense to pay for that tooling cost. Now, this HP 3D printing technology is a powder-based solution, and it's extremely fast. You can print full buckets of parts in just a matter of days, and it's a really great technology for that, and it's a good drop-in replacement for those injection molded parts. Another benefit is you don't require an experienced machinist to set up and run these machines. The system is mostly automated, so it really does cut down on labor and costs. So one application that uses this HP technology comes from Alcon. Alcon they're an eye care company, and they manufacture these surgical platforms for eye surgeries. And as you can imagine, they're not making hundreds of thousands of units per year. They're more on the order of a few thousand per year. So you can imagine a part like a blow molded duct, for example, an internal air duct, can be very expensive, because when you're talking about tooling for blow molded ducts, you're looking at minimum of $5,000 for a very simple mold, and it can cost up to tens of thousands of dollars for more intricate molds. So by printing these air ducts on the HP printer in-house, they were able to realize huge cost savings. Now, they did purchase this HP equipment. They have 2 full systems that are running full-time over at their facility, and they're seeing massive cost savings by printing these parts in-house rather than outsourcing them to be blow molded in a traditional method. So really incredible to see that these parts that are 3D printed actually make their way into a surgical device that goes into a doctor's office and is used safely with patients. Really great case study. And the last case study we'll look at comes from a company called Smile Direct Club. You may have heard of them before. They make invisible aligners. And this is not a new thing by any means. So the way you get these invisible aligners done typically is they will send out a kit to you. You take an impression of your mouth, send that into the company, they scan it, use some sort of software to digitally move the teeth into the desired position. Once you have that new model of where you want the teeth to be, you would print that off, and then you vacuum form your aligner tray. So kind of a lot of steps there, but it's a process that is typically very expensive, and 3D printing is not new to this process by any means. SLA technology, one of the oldest 3D printing technologies, you may know it as resin printing or stereolithography. This has been used in this industry for a very long time. It's very accurate and very high resolution. Problem is it's messy and it's slow. You have resin going everywhere that can be very toxic. You have to use cleaning agents, and it's not the fastest technology. Now, a company like Smile Direct has to produce 50,000 units per day. And keep in mind, everybody's teeth are different. So these are 50,000 unique parts. That is a massive manufacturing problem to solve. And the only way you can do it is with 3D printing. Now, Smile Direct Club purchased, I believe it's 49 of these HP 3D printers, and they brought them in-house. And they're running 50,000 units per day of teeth impressions. Now, by switching over to the HP 3D printing technology as opposed to the old SLA technology, it allowed them to save so much cost that they're able to sell their aligners for 60% cheaper than the competition. That's a clear advantage over their competitors, and it is helping their business immensely. So really another great application of 3D printing for manufacturing. These are really incredible use cases we talked about. It's no wonder that companies are turning towards additive manufacturing. So hopefully at this point, you're asking yourself, how can I adopt 3D printing? How can I benefit from this technology? Well, really there's two avenues. First way would be to purchase equipment. Like we saw the last use case, they brought this 3D printing in-house, and that will give you very fast results with a lot of control. However, the other side of that is that it does require a large capital investment. You do have to have the resources to run and maintain the machines. So that is one way you can adopt the technology. Another way is through outsourcing. So maybe you're not ready to purchase the equipment yet, and you can outsource it to a 3D printing service. And there's benefits to that as well, because you would have access to different technologies and expertise. You're not locked into one 3D printer with one type of material. You can access a whole variety. So really two ways you can go about adopting this technology. And Saratech can help you with both of those. We do sales, service, and training, as well as offering to outsource your print services. Now, all of the examples I showed you today, we have all of the technology to print those parts. We have the HP system, we have the Mark Forge system, and we have the Big Rep machines. We have very fast turnaround times. We're local here in Southern California, and we have competitive pricing as well. So let's say you're not ready to purchase a machine. We're more than happy to 3D print your parts for you. And by going through us, we have the additive manufacturing and product development expertise. We're happy to look over your parts with you, give you design feedback, maybe sit down, do a design for additive manufacturing review, and make sure you're successful when you are 3D printing your parts or adopting the technology. So, takeaways from today. 3D printing has come quite a long ways. There are so many applications we saw, and that was just 4 applications we saw. There are so many applications where 3D printing is saving customers time and money. And really, if you're not adopting these technologies, there's a good chance you're missing out on cost savings there. So the last takeaway is that Saratech, we have the expertise and engineers available to help you adopt this technology and realize this yourself.
Great, thank you so much, Andrew. So with that, I'm going to go ahead and turn it back to Nicole.
Oh yeah, at this point, we're all experts on 3D printing. No, seriously, we here at Saratech are the experts, and we're here to support you. We've learned today how to incorporate 3D printing into the product development lifecycle. And it was great to see how many industries are using parts that are 3D printed. For me, I'm grateful for the insight into Alcom as well as Centaur, who benefited greatly financially and time savings by embracing 3D printing. Andrew, thank you so much for teaching us how to adapt and why to adopt 3D printing with Saratech.
Thanks for checking out our channel. If you like what you saw, make sure to like and subscribe down below so you don't miss out on any new videos. Follow us on LinkedIn, Facebook, and Twitter for the latest engineering news and information. And to see all of our upcoming events, please visit our website at saratech.com/events.